In this video, we will learn about magnetic induction. Magnetism can be induced in magnetic substance by bringing a magnet near it, and this property is called as magnetic induction. In magnetic induction, there is no actual contact between magnet and magnetic substance, but even then, the substance behaves as a magnet. A magnet may attract another magnet or even a magnetic substance, but repulsion takes place only between the like poles of magnet. Hence, repulsion is a sure test of magnetism. Here we have an activity to show that magnetic substances behaves as a magnet when it comes in contact with a bar magnet. That is, we are trying to prove magnetic induction. Materials required are a bar magnet and iron pins. Let's understand the procedure. Take a bar magnet and place it near an iron pin. The iron pin gets attracted by the bar magnet. Now bring another iron pin near the first pin. What do you observe? Here we have the observation. We will observe that second pin gets attracted towards the first pin. So this is the magnet which is attracting the first pin. We can also observe that second pin is attracted to the first pin. First pin is not a magnet, but still it is behaving as a magnet, which shows that magnetic induction has taken place, because of which this first pin starts to behave as a magnet, which is going to attract further more pins. So it shows that due to magnetic induction, the first pin is behaving as a magnet, and we can make a chain of pins if we bring more pins in contact. From this we can prove magnetic induction. Moving ahead, here we have important terms for a bar magnet. Some important terms for a bar magnet are defined here. First is magnetic poles. 2 points near edges of a magnet where most of its magnetic power is concentrated are called magnetic poles of a given bar magnet. Here we can observe these are the 2 points, that is North Pole and South Pole. These are called as magnetic poles. Let's understand about magnetic North Pole. It is the magnetic pole which always points towards geographical north direction when the bar magnet is freely suspended. In this figure, point N is the magnetic north pole. So we can say that whenever a bar magnet is freely suspended, it will always point north-south direction, where the north pole of the magnet will point towards geographical north direction and south pole will point towards geographical south direction. So the magnetic south pole is a magnetic pole which always points towards geographic south direction when a bar magnet is freely suspended. In this figure, point S is the magnetic south pole. This is the south pole, whereas this is the north pole. Next is magnetic axis. An imaginary line passing through the poles of magnet is called its magnetic axis. So here we can observe this is the line which is passing through the poles and we call it as magnetic axis. Then we have magnetic length. The distance between two magnetic poles of a bar magnet is called as its magnetic length. Thus, magnetic length is equal to the distance ns. So here we can observe the distance from this point to this point would be called as the magnetic length. I hope this topic is clear to you. Thank you.